firstly, thank you, Apollo, for having me. I'm super excited to be here and talk about Booking.com's journey in migrating to the Rust router from our Node.js Federation version, and how we did it safely, effectively, and how it helped power up our product teams with new features and capabilities. All right, to get started, what am I going to talk about today? Today, we're going to talk about challenges of growing the supergraph, how we rolled out the router, and what we learned in the process. And then throw all your questions at me at the end. We can kind of dive into any area that you're interested in. So we're at an American conference, Booking.com. Our presence isn't always super huge in the US, unless you've been watching Major League Baseball lately. But to give you an idea of who we are and what we do, we're the world's largest accommodations platform. Between us and our sister companies like Kayak, Priceline, and others, we did over 900 million booked rooms a night in 2022. I don't have any updated numbers because I didn't have time to go look them up, but I believe it's over 1 billion per year at this point. So we've continued to grow and we continue to grow, and that's a key theme you'll see throughout this presentation. So let's dive into our graph. Let's understand a little bit about our scale and what's going on with Booking.com's graph. So currently, this last couple months, we've been doing about 12 billion requests per day. So some quick math, that's about 360 billion requests per month. We do up to 100 changes per day. All this is very much on the high end. Usually it's in the teens, but we do have to support this need. We have over 2,000 engineers that have contributed to the graph in some way in the last year. We have over 8,000 types and 180 subgraphs. So we have a lot of things going on. And on top of the subgraphs, we also have about 160-70 client micro front ends that access us, and that's excluding apps, apps like iOS and Android. So I have 99 problems, but I don't have time to talk about 99 problems. I'm going to talk about the top 3. We have when we started with Federation to scale with 12 billion requests per day, we had over 2,000 instances of Node.js Federation running. We ran this in multi-cluster mode, so we didn't have 2,000 pods going, but we had a lot of instances, and this made rollouts hard, difficult to maintain. Rollouts would easily take a couple of hours because of the sheer number of pods we had. We saw a significant impact as our queries grew in size. Things like on our search and hotel page were taking longer and longer as the query increased. And we saw that JSON.stringify is probably your slowest part in Node.js, no matter what you do. There ain't much you can do to speed it up. Now from that, schema updates were actually one of the biggest things and issues that we continue to see. And that was effectively, as the query plans were reprocessed and redone, we saw a huge performance impact. Effectively, our response time skyrocketed for about 30 seconds until those new query plans were generated. Now, these are problems, and problems aren't always necessarily a catalyst for change. So we actually have some things that I like to highlight that were specifically why we kind of said we need to move away from Node.js version of Federation. So first, we were growing double digits every year. When we started Federation, built the first version out, we were doing sub-billion requests per day. And that was just a couple of years ago. So we've grown over 12x in size. Now, in this time, our queries have become larger, more complex. They're growing in size every day. Whether that's from client-side requests or server-side requests, they were just getting massive. We wanted to support defer, subscriptions, REST connectors, and authentication directives and policy directives. These were things that teams said, hey, we think these are really important to help build better products for our customers. Now, on top of that, Apollo simply said, well, we're going to kill Node.js Federation at one point or another, so you better get a move on. So how do we make the router work at Booking? So the answer to this is pretty simple, experimentation. Now, Booking has a rich history of running experiments and A/B tests across our platform. We've been doing it for 20 years and celebrated our 20th anniversary early this year of our first experiment. I, myself, and many other of my colleagues have run hundreds of experiments, usually unsuccessfully, but we still shoot our shot, so to speak. And with this, with this experimentation capability, we validate our impact in a statistical significant way, which I think is really cool. So we check, not only are we increasing people booking, but are we improving customer satisfaction? Do we see increase in CS? Are we decreasing page performance? We have all these metrics and things that we tie to ensure that our experimentation is successful. It also allows us to do page-by-page traffic shifting. So we can kind of see, OK, how does it impact our homepage versus how does it impact our search page versus maybe the reservation page and all these different things. We want to see where this impact comes from the router. And then another big thing is at Booking, we didn't do a lot of infrastructure scale experiments. They're really tough to do, and we'll talk about some of those challenges in a second. But we wanted to see where could we start improving and where are kind of those cuts that we can kind of heal up and make better for everyone else as we started to run more infrastructure experiments across the company. So before we dive in, we got to understand our infrastructure just a little bit. And I've put together a couple of really high-level diagrams. So for client-side rendered requests or Android or iOS requests, before the GraphQL request comes to us, it actually goes through user context enrichment. This gives the locale, the language, the currency, and a bunch of other information about the user in the request. And that's added to the GraphQL request and gets sent to Apollo Federation, or us on our team. Now, keep in mind that proto. User context converts the request to protobuf, and that was a bit of a sticking point, and keep it in mind as we go forward. Server-side request, our micro front ends will actually request the user context. They'll embed it because they do certain things with it, maybe to display certain components or pages or changes on the page. So with that in mind, they actually still send us this JSON in a regular GraphQL format. So that was really good for us. Now, how do we actually set up our experiment? So for client-side requests and apps, we set it up like this. The user context enrichment provides the perfect place to do our coin flip to say, OK, are you going to go to variant 0, which is Node, or variant 1, which is the Rust router? Now, this is a great place because we can control it and then set up as many experiments we want in the user context service to do that coin flip. And we did this simply by setting a header and letting our service mesh kind of take care of the routing for us for the different services. Now, with server-side rendering, a little trickier. We have hundreds of micro front ends that run, although we do have underlying core libraries for them. So we gave the ability for micro front ends to actually opt into these experiments and set up their own experiment as they wanted to test. We also then, in the core library, made our own experiment to do a forcible split of traffic as well, once we were ready to do that. But we're going to let teams kind of piecemeal it out and go slowly so we didn't disrupt their traffic or cause any other issues. But the micro front end was responsible for flipping the coin and tracking metrics, which ended up being really nice because then we can do page-by-page experimentations and run against that. So now, I said earlier, infrastructure experiments are really hard. Like, they're really, really hard to get right, and not because necessarily the technical aspect, but setting up a good experiment is controlling the variables. Now, if you think about this for a second, there's actually an issue with this experiment setup, and there wasn't really a great way around it. So as we decrease traffic to Node.js, to move it to the router, it gets a little bit of a performance advantage because we've just reduced the traffic. And we can't reduce our number of instances because if an issue does occur, we need to be able to turn that experiment off and flip traffic back immediately. So effectively, it wasn't as apples to apples as we want, and we had to take this into account as we kind of generated reports and looked at things. So this is one of the biggest things with infrastructure experiments. You can also see with the micro front ends, we had to get 180 services to roll out and update. Not super ideal either. And because of this, there actually have been changes within Booking that we're starting to do to have be able to do infrastructure experiments like this much easier. But with that said, we ran a whole set of experiments, and these are kind of the high-level view of it. So I talked about that protobuf thing. That was a huge thing I wanted to do for actually a couple of years, but I could never get buy-in for it. And we did protobuf to JSON. We ran this as an experiment with that user context because, well, writing the protobuf decoder and everything for the Rust router was practically impossible. The issues we ran into were to do it, we had to do some memory hacks and a bunch of other stuff to get it to work. And we said, this really isn't safe. It's really not what we want. So we actually ran an experiment, and you know what we saw? We saw nothing. It was the most uninteresting results you'll ever see, which is a good thing in this case. So no performance or customer impact on that. We then ran search and property page. We ran these first and simultaneously with protobuf to JSON because they're all server-side rendered. So we're ready to go. We didn't need to do any conversion about that ingest traffic. And so that was really nice to start seeing that and seeing kind of the big heavy hitter pages that use a lot of GraphQL and how that performance was impacted. From here, we did miscellaneous app pages. We also have kind of a BFF micro front-end architecture for some app pages. So we tested that as well, mostly like the home page of the app and things like that. And then we also have native app components that we did a split of traffic as well on. And then once everyone was rolled out, everything was ready to go, we forcibly did a 50-50 traffic split. 50% of the traffic goes to the Rust router, 50% goes to Node.js. And we got to see the results from that. Now, I'll talk about that in a little second. I want to keep you hooked just a little bit longer, so you keep paying attention a little bit to this presentation. Now, how did we end up building the router? So one of the challenges was getting buy-in for Rust. If you're not aware, Booking.com still uses Perl. We were built on top of Perl from 1996. And telling someone like, hey, we're going to do Rust is a bit of a tough pill to swallow for a lot of people. We use Java, we use Node. I was there around when we tried to get Node adopted. It was painful. But luckily, a few things happened. Our developer experience teams recognized the need for other languages, notably Python, Rust, and more adoption of Go, beyond just the Kubernetes work that we do. And for this, they set a guideline for community standards and things, and a community-supported language. So we worked to build, with some other developers across the company, a Rust community group. And this was one of the fundamental things to make the Rust router work for us, as we were going to need to do customizations that I'll talk about in a little bit. So from here, we need to find plugins and integrations and customizations. Booking.com, large enterprise, we're going to customize whether we should or not. But there are actually a lot of things that we do need to customize. We've been around for 30 years. We have our own event system that is being deprecated. And we have other systems that we need to kind of integrate with that aren't fully standard across the industry. So these are the things that we kind of need to work on. So from here, we also need to find custom metrics. We love metrics. If you saw our metrics bill, your eyes would open up and you would think that we're insane. We probably record a bit too much. But we needed to make sure we moved everything and address what was good and what was not working. So we made a whole list of that as well. And then also design a testing hierarchy. This is, to me, one of the most important parts. We're introducing a lot of change, introducing a new language, a new framework, a new router. And all eyes are on us during this. So we need to make sure our testing strategy is rock solid. And to be honest, our Node.js testing strategy was so-so. I'm partially to blame for that. We didn't really do a whole lot of emphasis on making it as good as we should. But with Rust, we wanted to change that. We said the testing needs to be fantastic. It needs to work really well and catch as much as we can. And I'll talk a little bit more about that in a second. So let's talk about customization a little bit and what we did it for Booking. So one of the questions is, how do we decide what to do the plugin? YAML, Rye, Rust, or a coprocessor? So we came up with this flow chart, and there are a couple asterisks to it we'll talk about. But this flow chart kind of defines our thinking process quite a bit. So with it, do we have a need for speed? And if you answered no, you're wrong. We always have a need for speed. We got looked at a lot as the gateway being slow. We never were actually all that slow in the grand scheme of things. But people kind of thought that, and I kind of wanted to put that debate to rest by being as fast as possible. So we avoided coprocessors for the time being. So on top of that, we said, can the logic be defined in the YAML or without actually writing code? If so, always do YAML. Config over code in every case if possible. Do we need metrics? If so, Rust is the way to go in that case. If not, do we then need file access or other network calls as well? If not, Rye was always perfect. We didn't really see a performance impact with Rye, so we decided to be OK with leveraging that as much as possible. But if we didn't need network, we need to go back to Rust as well. So from here, what did we actually end up customizing? Well, feature flags. Booking.com has our own internal feature flag system. We are moving to open feature flags, but that wasn't quite ready for us. So we had to write a feature flag library integration for our system. And out of this, we also, another colleague of ours on another team, wrote the open source open feature flags for Rust as well that we're looking forward to adopting. So from here, Booking has custom events. This is a bit of a late minute addition as we were going to use open telemetry events, but it turns out there were some uses that we needed to do with Booking custom events still. So for our custom events library, we had to build that library as well. Of course, that was done in Rust. Then URL writing for reverse proxy. This can be done in Rye, but it was the first plugin that we wrote when we started experimenting with the router a couple of years ago during a hackathon. That one just kind of stuck in Rust, but we will eventually migrate it to Rye one of these days. Extensions pass through. That user context is added to extensions, so that needs to get passed through. So So this is a good one, maybe Apollo. You can add this in as config. Would super love to have that. And that's one other plugin we can have off. S2S authentication. So this one was a bit interesting. So with S2S, we make a call to a sidecar to effectively get our tokens for service-to-service calls. Now, this is actually a great place for a coprocessor. We send the request. It gives us the token back based on the parameters of the request that we send. Unfortunately, we couldn't get buy-in for them to change their API to help us out. So we had to write a service-to-service authentication plugin in Rust to get that to work. From here, SLI header generation. This is one of my favorite features that we've done. Effectively, we add the operation name into the request or in the request header, and then our service mesh can generate a bunch of SLOs, SLIs off it based on what a team needs. So it makes it really easy for teams to do it, and we wanted to keep having that going. And then we do error masking as well, so we have an allow list for what errors or error codes are allowed to get back to the client, just to make sure we don't leak any data. So I talked about testing, and I think testing was one of the most important things that we did and kind of the best time spent of the router migration. So with it, every test or every plugin had to have a comprehensive unit test. We used AI to help us write quite a bit of it, but also kind of suggest ideas of what to test as well. So the initial plugins were always reviewed by pretty much everyone on the team to make sure that we caught everything. And then with integration and EDE testing, we actually put a lot of effort into here as well. We had a bunch of new stuff that we were going to be implementing, a new custom rate limiting directive, bot scoring directives, customizations, authentication, and policy directives as well. So with this, we wanted to make sure that we had kind of an environment where we could actually test and validate these things really well. So with that, we built a whole infrastructure design to spin up a custom supergraph and a custom set of subgraphs that we could actually test and validate all these things instead of relying on maybe our own custom subgraph in our current federation and then pulling on that as well. So testing has caught a lot of issues that we've gone through, and any test that we do or any plugin that we add, we make sure that we have comprehensive testing around it. So this was really important as we really strongly believed before we started the single request to go through the router in production, we wanted to make sure that we had these tests first. So we made sure that our testing was incredibly comprehensive. So, okay, I kind of dragged you along a little bit. So actually, what did we see? So I think this was brought up in the keynote a little bit. The numbers were a bit wrong in a positive way because they're actually better than what they actually said. That's probably a first in a keynote. So we actually saw about a 60% reduction in infrastructure use. So number of pods were used. We do think this could actually probably be a bit lower, but we haven't done super dramatic pod tuning, but this is kind of what we saw on the initial thing. Our largest queries, like full search, which take over 200 milliseconds to process on the gateway itself, were reduced to like 20 milliseconds. So in many cases, we saw around, with the largest queries, about 80 to 90% reduction in query processing time. This was huge for us. Although our subgraph still takes 3-4 seconds, if you can shave things down from 200 to 10 milliseconds, that's a win for everyone. Now, one of the main things that we monitored during this was web vitals. So if you're not familiar with those, there's like least contentful paint, time to first byte, and a bunch of other stuff. I'm not a front-end engineer, but they're important to monitor. And one of the initiatives that Booking.com has had for the past couple of years is making our website more responsive and faster for our users. So what we saw and monitored this in experimentation was about a negative 16 millisecond across the board on these ones. And now you may be saying, you just told me you took off a couple hundred milliseconds off a request. Well, yes, but there are other things with parallel requests, and one request comes in and they do another request based on some data. So we don't get all those advantages to the client side, but negative 16 milliseconds was one of the larger impacts that we saw on the infrastructure side, which was super great to see, and people were very excited about that. So with this in the Rust router, what capabilities ultimately did we unlock? So security directives were a big one. So authentication directive, policy directives that we're going to be leveraging here more and more, give a first kind of a first gatekeeper for authorization authentication for teams, making it easier to enable this for them. So that was super good. Teams were always unsure, why can't you do it? Although we do believe every stage should have auth-C, auth-N. This is just one more area to have it in. Enhanced observability for teams. We put a lot of effort into new metrics with OpenTelemetry. We moved from Graphite to OpenTelemetry as part of this project. And so with that, We added new things such as error code, metrics, and a whole bunch of new stuff so teams can really quickly build out their own boards for their own subgraphs or operations that they want to monitor and they feel are important. And we made it really easy for teams to build SLOs and SLIs on top of this as well for them. We laid the groundwork for subscriptions and defer completion. So with this, we have the user context service still in front of us, so that makes some challenges into getting subscriptions and defer working. But effectively, we've laid the groundwork for it. Teams are super excited to start leveraging that, and we're going to have it hopefully ready in Q4 for our teams to start using that. And then connecting legacy data sources is even easier. I mentioned that we still have Perl services, right? I don't know who here wants to write a GraphQL Perl integration. My guess is no one. I don't want to do it. My team doesn't want to do it. No one in the company wants to do it, and we have Perl engineers, some of the best in the world. But the fact is, no one's doing it. So REST connectors are a huge win for us in that regard. And also getting certain teams that aren't quite sure if they want to use the graph or not onboarded very quickly. So what are the key takeaways of this in a router migration? So validate your changes with data. You can't just say, I think this is going to be better. It's always best to prove that it's better. And we were able to prove that it was better. We had no negative customer impact, and no necessarily conclusively positive customer impact either, but we saw infrastructure impact, improvements on infrastructure. We had these numbers that we could share with our leadership and say, hey, yeah, we took a bit of a gamble with Rust because we did need to do quite a bit of customization, but it paid off in the end. We're saving hundreds and hundreds of thousands of dollars a year. And as we move more and more of our workload to AWS, I think this is more important as well. And as you go into this, think about your customization. Think carefully. Do you actually need that custom plugin? Is it actually going to be useful for it? We actually did not move every plugin over from Node.js. We said, you know what? We don't feel people are using this, or we don't feel it's needed. Let's not move it over. And we took that very pragmatic approach. And then also how we chose whether to use Rye, Rust, a coprocessor, or YAML configs. And then ultimately align this with the business. What are their goals? Our business goal was to improve the page performance. That was an easy connection. But we also made a lot of other connections as well. So if you can make these, it's a lot easier to have buy-in from your company about starting to leverage Rust and other things as well. With that said, any questions?
If you have a question, raise your hand. I'll bring the mic to you so everybody can hear.
Hi, thanks for your overview. So you kind of touched on rate limiting. You mentioned that there was a custom implementation. I just want to make sure I got that clear right. So what, if any, investigation did you go into the Apollo router rate limiting, and what kind of differences did you have with your custom implementation?
So with our rate limiting, we provided a directive that accepted a number of parameters for what we want to do rate limiting. And we did this because we actually have rate limiting infrastructure within Booking. So we have a whole service that can help you monitor and define rate limits and set them as well. So this rate limit plugin under the hood, it does a whole bunch of things to collect the information and send it off. And effectively, that service can simply say yes or no to continue to allow this. So it does all the aggregation and things like that for us, so we don't have to do it. So we hooked it up with that.
Thanks.
One back here. I'll come to you. I'll get you.
Hi. So considering your scale, right, what was your go-forward approach for observability? Was it customization at every layer, or you just leverage it over to a SaaS product like Datadog or something?
So I'm just to understand. So for us, we have our own OpenTelemetry ingress or collector system. I don't know if it's custom built or semi-custom built, but effectively we use that ties into Grafana. So we have Mimir, and that absorbs all the metrics and telemetry. We were the first large user of it. And so we definitely got to cut our teeth on OpenTelemetry a little bit as part of this progress. And we're still cutting our teeth a little bit on it as we continue to scale up, as they weren't quite expecting the sheer number of 12 billion requests per day and the observability that comes along with that.
Were there any particular metrics or customizations that really helped with your teams kind of adopting and being on your side that they didn't have before? Since you mentioned some of the custom metrics you got to add in with Rust.
So one of the big ones that I was really happy to add was better observability into what codes are returned from the subgraphs or even the router itself and have those as open telemetry labels. So that was a big one for teams to be able to say, oh, okay, it looked like this. And that provides a really easy way for teams to effectively say, okay, is it the router having an issue? Which, we've customized a lot, so it could be the case. But 99 out of 100 times, it's the subgraph having an issue. And they can easily identify what subgraph is affecting their operation, or if it's just their subgraph in general that's causing the issue.
It was a good presentation. I would like to know, you talked about experimentation across pages, right? I want to hear any issues you ran into and how, what was that something you did for router to mitigate those issues? And how was, how long were your A/B tests? Like, were it for multiple weeks or multiple months?
So the first question is about issues that we face with experimentation on a page level. So we didn't really face any specific issues. A big one was we had to run, because of that protobuf to JSON, client side and server side as separate experiments. I didn't really want to do that to begin with, but we wanted to kind of get a move on seeing how this works. As they worked on it, the protobuf to JSON conversion was actually a lot more complex than anticipated. But those were kind of the things, because effectively you could have a page where search is always the one I use as an example. You have below the fold, we load more search results in. That becomes a client-side request, although the initial one is server-side. So you kind of have these skewed metrics on if you're looking at the page as a whole. So experimentation always looks a little skewed in that regard. But we're able to adjust for that accordingly. So those were some of the things. And then the second part of your question was?
I think you answered the first. Second one, the first part was, were there any issues with the router? Like when you had behavior difference, right? Any function?
Oh, okay. So actually any behavior differences. Not in a negative way, no. So we actually had a bit of a sticking bug with a product that we were trying to release. I eventually found the bug in the Node.js version, or tried to understand it at least. But effectively, it was fixed in the Rust query planner. So it was overall very positive. And I think the other thing you asked was the runtimes of the experiments. So for property page and those ones, I believe it was 2 to 3 weeks. Although bugs and things like that, we had to restart a few times. Mobile apps was the longest one since our adoption there is limited. And that was the only one that we said, because the runtime was supposed to be like 450 days to be significantly significant, because of our traffic there is a bit more minimal with GraphQL. We eventually said after, I think, about 60 days, this is good enough. It's probably fine. Can't run everything super scientifically at the end of the day, right? So that was how that went.
One of the metrics you mentioned, the 100+ graph changes per day potentially stuck out to me. Are those distinct subgraph deployments? That is easy.
Yeah, that would have happened. Yeah.
Okay, and so I guess how do you manage that and make sure that the teams aren't stepping on each other's toes? Or do you have a lot of entities in your graph?
Not as many as we should. So that is kind of one of the things. We are working more and more with teams to start leveraging entities where it makes sense, and we're starting to identify that with the help of AI and some other stuff that my colleagues will talk about in a presentation tomorrow. But that also makes things a little bit easier in that regard. 100 is the far off. That's the 99.99999 of the changes. Most of it's only about 10 or 12 changes a day.
I think I heard you mention coprocessor, and not yet. Do you have plans to use it, or have use cases that you're getting kind of challenged on potentially use it?
I would like to get the service-to-service stuff moved over to coprocessor so we can remove that library out if possible. We have been discussing internally rewriting the service-to-service authentication sidecar in Rust. There's been a POC a couple months ago. Really great results from that, and maybe I can convince them to give us that API we need to make it easier. But overall, no, we don't really consider a coprocessor because of, we'd like to use coprocessors, or not coprocessors, but sidecars a lot within booking. And there are certain challenges with it, scaling them, making sure they can work. And we see the coprocessor likely being a drag on the router's total performance in the sense of how do we scale that coprocessor up with the router itself? Because if you write it in Node, it's obviously going to be a lot slower. You're going to have other issues. So we also think the simplicity of not using it is a win. Yep.
Yeah, I was curious specifically about your end-to-end approach to testing. Do you do that in prod, or do you not, or destructive, non-destructive?
So there's a lot of testing that's going on. I didn't say every bit of testing. So end-to-end testing is effectively a custom instance that's fired up with our own subgraphs and our own clients, so we can actually track what's going on. We have experimented with traffic replay in the past. There is an infrastructure looking to do so, but it has when you're running it in prod, it has a notorious impact of impacting experimentation results if the underlying service isn't aware that you're doing a shadow traffic. So what we've ended up doing is then for production, we just run canary pods just to make sure that everything is running safe. Very small % of traffic, we monitor it, make sure it looks good, and I continue on if needed.
What was your legacy infra from where you moved to router, and what was the key driver for that?
What do you mean by legacy infrastructure?
I mean to say, were you already on router before this? Sorry, I missed the earlier
Oh,
part
no.
of
So we were on Node.js version. So we're on the Node.js router, and then this is moving, or gateway, Federation gateway, to the router. Yeah.
And that was just for improving the performance, you said?
Improving performance, unlocking new features, and a whole bunch of other reasons behind it. Yep.
Thank you.
Hey there, thank you very much. Just wanted to ask or get more insight on how you manage the initial bump when you're onboarding to Apollo. I guess like the first team that adopted the sort of the whole graph idea, and then the other teams had to buy in. How do you manage that initial sort of takeoff, especially with going from REST and Perl into more graph-oriented?
Okay,
From a more like hands-on perspective.
Yeah, so that's a great question. So I wasn't there at the early days of the team. I was about 1 year late. But the idea, what happened was there's actually buy-in immediately from the underlying micro front-ends team. We originally experimented with doing like protobuf calls to our services. We used gRPC protobuf for a lot of stuff. There was a lot of performance issues with that within Node.js and doing things. So what effectively they had settled on was a unified way to do data access, which was GraphQL. And so it was kind of a forcible push to get people to adopt. So it was one of the very few times in booking that we've said you kind of need to adopt this versus allowing teams to do it.
Thanks for sharing. At this stage, now that you're onboarded on router, what would be like your next questions or wishes for the roadmap of the router?
Oh, next questions, next wishes. Putting me on the spot for that. So I think stability improvements. Overall, we haven't really had much issues with stability, but we continue kind of metrics and observability. The one we've kept asking for Apollo is an actual metric of how long is the router taking to process the request outside of honeycomb traces, or not honeycomb, but OpenTelemetry traces. This is the one thing that we couldn't move from our Node.js implementation. And we actually used to set SLOs and SLIs on that. So that is one feature that we really want to see. There is some interest in doing like REST connectors via like gRPC or protobuf, being able to kind of extend those a bit further. We can, a lot of our Perl services use gRPC or protobufs to communicate, so they're not quite ready for REST connectors, for example. So those kind of things I think would be really important. There's some other customizations and security customizations that we'd like to see as well, because we just implement them as custom plugins. But yeah, I mean, flexibility, we hope that Apollo continues to allow us to do like Rust plugins, because at the end of the day, we need that flexibility to do what we need to do.
Hey, so I have a question around the federated services, like the subgraphs services. Were there any implications with this change? Would they have to change the way that they collaborate on the schema, the way that they push changes to it and stuff like that?
No. So one of the things that we did was we made sure that we minimized impact to subgraphs and clients alike as much as we possibly could. So subgraphs had no changes they needed to make other than updating their observability dashboards from going from Graphite style metrics to OpenTelemetry metrics. Otherwise, it was transparent for them.
Hi. In the REST world, there's this developer portal, all the developers get to see various APIs available, right? How does a developer at booking.com discover the operations, GraphQL operations?
Sorry, I didn't quite understand the question.
So in the REST world, REST API world,
Yeah.
there is this developer portal, which renders the request, response, the URL to call the API
Yeah.
and all. How does a developer at Booking.com discover the GraphQL, operations?
Oh, okay, great question. So discovery and observability. I don't want to take too much from my colleague's presentation tomorrow about that, but that's still a continuous work in process. So right now, there really isn't like a specific method other than browsing the supergraph and understanding what's going on. Even with 20,000 type or 20,000 fields, about 8,000 types, you can still read it. You can still comb through it pretty quick, although you might miss things. So we are looking at AI-driven approaches to help consumers find it. We've been working on what we call text to GraphQL to generate queries based on natural language and those kind of things for discoverability.
All right, we've got time for maybe one or two more questions. Any last questions before we? Okay.
Here.
Yeah, great presentation. My question's around how did you know how many pods to run when you did for router when your initial traffic cut over, and did you have any? Do you have any recommendations for requests and limits? Oh, did you even set any?
So for the switchover count, that's a great question. So what we did was we took more or less two of the worst queries that we have, which are our property page query that calls, I want to say 6 or 7 subgraphs to get data. Should be calling more, but that's a different discussion. And then search, which calls 1 or 2 subgraphs to get information for. And then we spun that up in an instance effectively in production. So we had the same environment and same number of CPUs and RAM usage like that. And we fired off as many requests as we could to kind of see where the load went and see where it started breaking. With those two, we kind of understood that we can probably do about anything. If we can handle 2,000 of these requests on one pod, we can handle anything. And that's where I kind of said we still need to do performance tuning. I think we're a little over-provisioned in the sense of a number of pods. I think with some tweaks to Nginx and Envoy and things like that, we can get that number a bit lower.
All right.
Oh, sorry, yeah, your second part of your question. So requests and limits. So we don't really set any requests or limits. We set limits on query complexity, cost, depth. So we've had those set for years at this point, and we're a bit flexible on them as needed. We did have to reevaluate costs because we went from our own cost plugin to the one built into router. But effectively, we don't want to be a bottleneck for teams. So we don't really limit anyone directly ourselves. We do have rate limiting, at the edge and bot detection, all that kind of stuff. But for our router, we just say, we'll handle as much traffic as you can. Throw at us.
Thank you so much. That was really awesome. Really appreciate it.